going to take up the respiratory system, which is chapter 22. So functions of your respiratory system, I think everyone is familiar with it already. We took this up in your prereq. Some of these are just a review of your prereq, the parts of your respiratory system. So delivery of oxygen-rich air into the body and excretion of carbon dioxide out of the body. Filtration and humidification of inhaled air. How is air being filtered by your respiratory system? Anyone? How is the air being filtered, the air we inhaled, by your respiratory system? What are some of the structures that helps in the filtration and humidification of the air that we inhaled? Anyone? How is air being filtered? Huh?
Your lungs.
Okay. What are the structures that filter the air?
Alveoli.
Okay, what else? Start from your nose. What we have, what is present in the nose that filters the air?
Cilia.
You have your cilia, you have your hair cells. That is the first one that filters the air that we inhale. And then you also have what? What are other structures that is present there that filters the air?
Mucus.
You have your mucus. The secretions of mucous membrane is the mucus. It traps the dust, pollen, or other bacteria or viruses that is present in the air. It is being filtered. It is being trapped by your mucous membrane. And then humidification of the inhaled air, you have what we call the turbinates or the concae. These are, let me see, I have the concae here. This is what you call concae. And also the blood vessels that flows on the nose, there are a lot of capillaries present in the mucous membrane. And it humidifies the air. It makes the air warm before it can be transported to your pharynx. So filtration and humidification starts on the nose with the cilia, with the hair cells, and then with the mucous membrane producing mucus. And then you have also your mucus secretions and cilia in your throat. Those cilia are present, but those who are smokers, those cilia are destroyed. The cilia in the throat are destroyed for smokers. Regulations of acid-base balance. Remember, carbon dioxide is carried by the blood, by your venous circulation. When the blood is mixed, when the carbon dioxide is mixed with the venous blood, there is an enzyme that catalyzes the carbon dioxide and it mixed with water that is present in the blood. Blood is made up of water. And when carbon dioxide is mixed with the blood, it forms into bicarbonates. So bicarbonates is the one that maintains the pH balance of the body. It's one of the organs in the body that maintains the pH balance. When you say pH balance, this is the presence of hydrogen ions in the blood or in the body. When blood is mixed, when carbon dioxide coming from the waste product or the metabolism of the cell, so carbon dioxide is mixed with the blood, it forms into water and it forms into bicarbonates. When you separate bicarbonates, let me see, show you. Stop share. Let's go a little bit of. Oh, bear with me because I don't know how to use this very well. So this is your CO2. Oh my goodness. Cannot. So that is your carbon dioxide. And then when it comes with your venous blood, let's say this is your blood. I don't know how to use this because the one I had before on my computer, I can write on the screen. This one I can't. So your carbon dioxide plus venous blood. Blood has water. Blood is made up of water and protein. So that is the chemical formula of water. So when you mix carbon dioxide and water, it will form bicarbonates. And the structural formula of carbonates is HCO3. And this is the waste product of metabolism. So that is your bicarbonates. And this is the one, the hydrogen ion. That is the one that is responsible for the pH of the blood, pH of the body, the hydrogen ion. So when the hydrogen ion is high, then the body is in alkaline. More hydrogen. Body is alkaline. And if this is less hydrogen, the body is acidic. So that is the waste product of metabolism, your bicarbonates. And when it reaches the lung, these bicarbonates is catalyzed into carbon dioxide. So when it reaches the lungs, this will be broken down into carbon dioxide and water, and carbon dioxide is the one that is being exhaled. When we breathe out, carbon dioxide is the one that is being expelled, and water is retained in the blood.
So can you explain why, for smokers,
The cilia
are dead? They die from the smoke. But so if you don't have the cilia, and what happens with the carbon dioxide? You're not able to expel it?
No, you're able to expel it. The cilia in your lung, in the throat, is for filtration of the air that we breathe in. So you will be less filtration of the air that will go to your lungs. That is the functions of your cilia. When you inhale something that is toxic or maybe a virus or a pollen, it will irritate your throat. But for people who are smoker, the sensations that is different when there are cilia that is present there. They are more sensitive compared to smokers.
Okay, but it has, I guess, with somebody that smoked for a long time, I guess I'm wondering about the CO2. What happens with that? Because are you unable to metabolize it, or what?
Yeah, you can expel those carbon dioxide, same as those, but when it comes to filtration of the air that you breathe in, those smokers, less filtered air that will go into their lungs.
Okay.
Where is my power on? Oh, this one. I lost my slide. Is it this one? I lost my slide. So that is how the the respiratory system regulates the acid-base balance. When the blood when the carbon dioxide, that is the waste product of metabolism of the cell, is carried by the blood going to your lungs, it is the lungs regulate the acid-base balance, the excretions of carbon dioxide and retention of hydrogen ions, and productions and modulations of various sound. So you have your larynx, that is part of the respiratory system. The larynx and also the sinuses, the air-filled cavity, it modulates your voice. That is where the sinuses are part of the respiratory system, and of course, olfaction, sense of smelling. So the respiratory system is divided into two. You have the upper respiratory and lower respiratory. Anything above your neck, that is your upper respiratory. Below your neck, that is your lower respiratory system. So on the upper, you have your nose, nasal cavities, the pharynx, the larynx, and the trachea. So in the nose, we have your cilia. That's the number one that filters the air that we breathe in. And then you also have your mucous membrane, which secretes mucus and traps all those dust. Underneath your mucous membrane, you have your olfactory nerves, your sense of smell. That is located under the mucous membrane that transmit information to your temporal area for interpretation. Whatever you smell, it will be transmitted by your olfactory nerve, your first cranial nerve. And then you have also the pharynx. Oh, here you also have your turbinates. This is your turbinates. It makes the area for the air to be humidified, to make it warmer before it is transported to your pharynx. That is your turbinates or conchae. And then you have your nasopharynx. That is the passage of air. And the pharynx is divided into three. Remember this. Pharynx is divided into three. You have your nasopharynx, you have your oropharynx, and you have your laryngopharynx. Nasopharynx is also passage of air, while the oropharynx and laryngopharynx is passage for air and what? What does pass through your oropharynx and laryngopharynx?
Food.
Food, air and food. So it's part of the digestive and respiratory system, your oropharynx and laryngopharynx. And then you have your larynx. In the larynx, you have your vocal cords. And then you also have your Adam's apple. And then you also have in the larynx, you also have your epiglottis. What is the functions of your epiglottis? Epiglottis is a cartilage. And what is the functions of your epiglottis? Anyone? What's the functions of your epiglottis? This is your epiglottis.
To open and close your throat.
Okay, it closes your throat when you are
swallowing.
When you are eating.
Yeah, when you're eating.
No food will go to your trachea. So the cartilage will close it. So no food will go to the trachea. And then you have your true and false vocal cords. And the vocal cords is affected by hormones in male testosterone. When the boys reach their pubertal age, the vocal cords become longer and thicker. And that's the time when the voice of the boys change. It becomes more deeper because this is affected by the hormones testosterone. So that is your larynx. And then you have your trachea. These are cartilaginous rings. And what can I say about trachea? Those cartilage, it prevents the collapse of the trachea. And it is held by a C-shaped cartilage. Let's see here. Okay. Another name for the common name for the trachea is the windpipe. And for the larynx, it's the voice box. Where is my sinuses? Oh, I don't have my sinuses. And of course, you have your sinuses. You have your frontal, maxillary, ethmoid, and sphenoidal. So you have those sinuses, and it makes the skull lighter in weight. Now we go to any questions on the upper respiratory. Did I miss anything there? You have any questions on the upper respiratory tract? The pharynx, the larynx. Okay, let's go to the lower respiratory system. You have the bronchi. And the lower respiratory tract, you have the bronchi and the bifurcations where the bronchi is divided into the left and the right. It is called your carina. It is the point where you're in the trachea where the bronchioles or the bronchi bifurcates into left and right bronchus. And then it will divide into smaller ones. Now we call it the bronchioles. And as it becomes nearer the alveoli, because of the tip of these bronchioles, that is where your alveoli are located, those cartilage gradually disappear. And then at the tip of those secondary bronchioles, you will find your alveoli. On the alveoli, the surface of the alveoli, the outer surface, you will find it has the capillaries, pulmonary capillaries. So you can see here. You can see the red and the blue, which is located outside of those alveoli. So that's what makes it a good gas exchanger. Good gas exchanger. The alveoli are good gas exchanger because of the proximity of the capillaries to the walls of your alveoli. So, and then you have your pleura, the covering of the lungs. You have your parietal pleura, which is the outermost membrane covering the lungs. And then you have a space, and then another membrane. It's called now your visceral pleura, the one that is attached to the lungs. Between the parietal and the visceral pleura, you have that space, intrapleural space or pleural cavity. And in that pleural cavity, let me see if I... Here. So you have here the coverings of the lungs. You have the outermost covering called the parietal pleura, and then the blue one is your visceral pleura. And between the two membranes, you have a space, and it's called your intrapleural space or pleural cavity. And in that pleural cavity, it contains a serous fluid, around 25 milliliters of fluid. And the function, what's the functions of that fluid between the membrane? What's the functions of fluid there? Huh?
To avoid the membrane wrapping on each other.
So the functions of the fluid is to lubricate, and so that when we inhale, when we exhale, the lung can slide. It can slide. We'll go to this later. So remember that it's called your intrapleural space or pleural cavity. Then you have your bronchial tree. You have the right and left bronchus. What is the difference between the right and left bronchus? Anyone? What is the difference between the two bronchus?
One has more than the other.
Okay, what else? Huh? What other difference can you see on the between the right and left bronchus? Anyone? The left bronchus is
Larger. And
shorter and wider.
The right, yeah, the right one is.
And
We'll do the left one. Wait a minute. You're saying the left one, as we're looking at it, the left one, or the left one if we turn around?
Okay, this is the
This way.
okay. So this is your right bronchus. The right
Okay.
bronchus. This is the right bronchus.
And that's the one that's longer, right? And
The right bronchus, this is the right one. This is the left one.
right.
Okay, so the right bronchus, it is longer,
Mhm.
and it is also, the position is more on a vertical compared to the left one, to the left side. That is the reason why most of the time, especially among children, when they put something on their mouth, they usually lodge on the right bronchus because of the position of the bronchi. On the right side, it is more vertical and it is longer, whereas on the left side, it is shorter because of the position of the heart. Okay? So right bronchus is vertical, more of the vertical, and it is longer, whereas the left bronchus is wider and shorter. And the bronchioles, this is lined with smooth muscle. So this is what you call the carina. This is the point where the bronchus bifurcates into left and right. Be careful because when you do the suctioning, when you have a patient who has an endotrach, be careful to reach this area because this area is very sensitive. It will hurt your patient and they will stimulate coughing. Can you imagine that they already had the endotrach tube and then the patient will cough? That's too painful for them. That's very traumatic to your patient. So when you do the suctioning of your trachea, be careful, be gentle. Try to practice with your hand. If you are assisting your patient, you have to have your hands gentle but firm. Be gentle but firm when you are doing some procedures with your patient. So the bronchial tree, it conducts air to the bronchioles, and the bronchioles are smooth muscles. It determines the diameter or regulates the airflow to the alveoli. The bronchioles determines how much air can pass through the alveoli because when your bronchioles are filled up with mucus secretions, then the amount of air that can go in and out is limited. The alveoli are small grape-like structures, or otherwise known as the air sacs, that exchange oxygen and carbon dioxide with the blood in the pulmonary circulations. We have two kinds of circulations. You have what are the two kinds of circulatory system that we have? Huh? Circulatory system is divided into two. What are those two forms of circulation? Anyone? Systemic and pulmonary circulations. So exchange of gases in the lungs is one kind of circulation. It's the pulmonary. It's just for the lungs. And when it transferred to the heart, that is your systemic circulation. So we have two kinds of circulations. You have pulmonary and systemic.